Hello, welcome to this video on functions. And let's start with an example. So example 1, we have the graph of y equals fx as shown. And in part A, I want the graph of y equals minus fx. So each point of the form xfx becomes x minus fx. So for example, the point 4, 7 becomes 4 minus 7, and 4, 7 will become 4 minus 7, so you're reflecting over the x-axis, and you can do that for all the points. Even 0, 0 stays as 0, 0, 8, 0 is 8, 0, 10 minus 2 becomes 10 plus 2, 12, 0 stays as 12, 0. So you simply flip it like so. F of x minus 2. Any point x, fx becomes x, f of x minus 2. So for example, the point 4, 7, to get a 4 here, because we know that f of 4 is 7, to get a 4 here, we have to make x equal to 6, because 6 minus 2 is 4. So only when x is 6 do you get an f of 4 here, which means you get 6, 7. So every point moves 2 units to the right. So 0, 0 becomes 2, 0, 4, 7 becomes 6, 7, and so on. So everything moves 2 units to the right to make this work. Let's try another example here. Part C. F of x plus 2 plus 3. So any point of the form x fx becomes x f of x plus 2 plus 3. So for example, 4, 7. To get a 4 here, I simply make x equal to 2. So everything's going to move 2 units backwards towards the left. So if I make x equal to 2, I'll get f of 4, which is 7. The plus 3 comes at the end, and it simply means that every y coordinate increases by 3 units. So you come 2 to the left and 3 up for every point, and that will give us a graph like that. So 4, 7 becomes 2, 10, and so on. F of minus x, x fx becomes minus x f of x. So 4, 7, because this is f of minus x, to make this f of 4, you have to make this minus minus x, so x has to be minus 4. So when x is minus 4, you get f of minus minus 4, which is f of 4, which is 7. So the point 4, 7 flips over to minus 4, 7, so you're basically reflecting in the y-axis to get the graph of f of minus x. And finally, as a wee reminder, f of 2x. This means you double the x coordinate and then you plug it into the function. So 4, 7 becomes 2, 7, because 2 times 2 is 4. We know that f of 4 is 7. So you get 2, 7. That stays the same. And all the x coordinates are half. A bit like y equals sine 2x, where the period is 180 degrees and not 360. Okay. And let's introduce a new function, and that's the modulus function. Modulus function is you just make everything positive, and how you sort of do this, mod x will be equal to x when x is bigger than or equal to 0. For example, mod of 4 is 4. The modulus of x will be minus x when x is less than 0. So the modulus of minus 3 is minus minus 3, which is plus 3. So everything just becomes positive. The graph of mod x, y equals mod x, well, it's just like y equals x when x is positive or equal to 0. But when x is negative, like say minus 7, modulus of minus 7 is plus 7. So you get your D shape. If I had a quadratic, like so. Y equals fx, y equals the modulus of fx. Well, that's positive to here, so that's all okay. Positive here, doesn't change. But all the negative coordinates, negative y coordinates, become plus. So this just gets flipped over like so. So that's the modulus function. There'll be more of that in the homework. Even and odd functions. An even function is symmetrical when reflected in the y-axis. So f of minus x equals f of x. Good example of that is the cos graph. F of x here, f of minus x, they are the same. And y equals cos x is an example of an even function, because f of x equals f of brackets minus x, and it's symmetrical about the y-axis. Another good example of an even function is y equals x squared, like so. A bit more about that later. An odd function is such that f of minus x is minus f of x. Such a function has half-turn symmetry about the origin. So if you rotate it around, it will fit in. A good example of an odd function, is the sine graph. Here's x, sine of x, minus x, sine of minus x. So this fits, f of minus x equals f of minus f of x. So sine x is an example of an odd function. Let's look at an example. Sometimes we can be asked to prove or to show if a function is odd or even, or neither. Show that f of x equals x cubed is an odd function. So all I would do here is look at f of minus x. Put the minus x in a bracket, like so. Minus x cubed is minus x cubed. Minus minus plus 3x. So we're well on the way there. Take the minus sign out. And there we have it. Minus this, which is f of x. So fx is odd because f of minus x equals minus f of x. And you just write that down. Inverse functions. Inverse functions you have to be quite strict with. An inverse function is a function that takes you back from exactly where you came from. So if you've got a domain and a range and you've got a function f, and an element in the domain is taken over by f to its image y, f minus 1 takes it exactly back to x. Y must return exactly to x. So strict conditions on a function to have an inverse. If, for example, we have fx equals x squared, as you can see, it's an even function. Enough of that. F of 4 is 16, f of minus 4 is 16. So therefore, f minus 1, 16 would be 4 or minus 4. But that contradicts my condition that you must get back exactly to where you came from. Must have only one image, so we must truncate the domain of fx, and we do. We simply eradicate that and we make the domain x bigger than or equal to 0. The inverse function, of course, is y equals root x, and this way you only have one image, one image that you're going back to as opposed to a choice. So we restrict it. Also, you can't square root a negative anyway, so we have that. You could have the minus square root if you wanted to choose this part. Let's say I wanted to find the inverse function for this. Well, first of all, you'd simply complete the square. Now that will give me x squared minus 2 minus 2 minus 4x plus 4. So take the 4 off the 11. and you're left with 7. Now the graph of that function, if I sketch it, you can see why I've already prepared most of the sketches. The turning point here is going to be 2, 7. You can't get anything, you can't make anything negative when you're squaring it. So the smallest value of x minus 2 squared is 0 when x is 2. So that's why your turning point is at 2, 7. And then it's a parabola, with this being the min. So you ignore all that and you truncate it to this. So the domain x member of R, x bigger than or equal to 0, and the range will be y member of R, real numbers, and y bigger than or equal to 7. And that, of course, is not a 0, that's a 2. Here's my domain here, and here's the range here. To get the inverse function, you simply let this thing equal to y and change the subject. So you would get y minus 7 is x minus 2 squared, square root both sides. Then take the 2 over. And that gives you the reverse operation, so we'll squeeze this in here. F minus 1x would be the square root of x minus 7 plus 2. And you can see that you can't square root a negative, so x minus 7 must be bigger than or equal to 0, x bigger than or equal to 7. And that's x bigger than or equal to 2. I don't know how I got that. Anyway. So there you have that. Let's do another example, then you will get a chance. Find the formula for the inverse function of this y equals x plus 2 over x minus 4. Simply let y equal it, and then change the subject. So cross multiply, so you get yx minus 4y is x plus 2. Get all the x's in the same side. You can take the y over, take out a common factor of x. And finally, x would be 4y plus 2 over y minus 1. Therefore, I can conclude my inverse function is that. And that will take you back. Right, your turn. Lots of graphs to be drawn here. So pause the video and try these. Is everything in? So there's questions 1, 2, 3, and then 4 and 5. So enjoy, and when you're finished, here are the solutions now, so you can restart your video. Question 1. Question 2, just note that if, for example, x is 2, 2 to the x is 4, and 3 to the x is 9. So 3 to the x is always above 2 to the x here. But then when you're in dealing with negatives, like say minus 2, 3 to the minus 2 is 1/9. 2 to the minus 2 is a quarter, and a quarter is bigger than a ninth, so it dips underneath. Not drawn brilliantly, but there you go. Question 3. This is quite an interesting one. It just moves along 3 and up 4, and you get your T shape there. Question 4, worded a bit oddly, but anyway, function is even, function is odd, and neither odd nor even. It sort of mixes incompatible things here, so neither odd or even. Question 5. Are we all in? Question 6. 5 is there. There's part B. There's part C. Part C really does show you that if you put y equal to x in, y equal to x, you get the symmetry between this function and its inverse. Very important to remember that when you flip it over y equals x. And there's the rest of that. And part D, which was quite interesting. This is quite easy. This is just a bit of algebra. So you get f minus 1x is root 1 minus x over x. This graph here, when x is 0, you get 1. So 0, 1. But to the right of that, if you come down here, when you make x bigger and bigger and bigger, you're going to get 1 over something very big. So this is tending towards 0. And similarly here, this is tending towards 0, but towards as x gets big and negative. When you square a negative, you get a plus, so 1 over something. So you get this. Never actually gets to the origin. So the domain is x such that x belongs to real numbers. X is big when equal to 0. You have to truncate it because you can't have choices like y equals x squared. And the domain is from 0 to 1, not including the 0 because you're never going to get there. And I hope you enjoyed that. Bye just now.